Hi and welcome to this third video on data interpretation presentation. It's histograms and frequency polygons. Well, I say it's histograms and frequency polygons. It is basically histograms. Frequency polygons don't get much of a mention, but I'm going to just touch on briefly. But primarily we're looking at histograms, and again, it's stuff that you've seen from GCSE, but again, the questions tend to be set up in a more kind of slightly technical problem-solving type of way at A level. So let's just kind of go through the basics and have a look at a couple of examples. So here we go. Histogram, let's just go back to the beginnings just in case there are those of you that may not have seen a histogram before. So it's basically a bar chart, but for continuous grouped data. And the big difference between a histogram and a bar chart is the frequency, i.e. the number of pieces of data in a particular category, is not represented by the height of the chart. It's actually represented by the area of the bar. And technically speaking, it's the area of the bar is proportional to the frequency. So we get that. The area is proportional to the frequency. And, you know, from kind of studying proportionality again at GCSE, we can write that the area is K times the frequency. Now, that's the technical definition, but I've got to be honest, that bit there does overcomplicate it a little bit. And as the more we go through this video, you'll see what I mean. Bottom line is that it's the height of the bar, in this particular case with histograms, is referred to as frequency density. And again, that's hopefully a term you're familiar with from GCSE. So if we have a look at any particular bar, we've got the class width, we've got the frequency density, and the area, which is the frequency, is going to be those two things times together. So area is class width times by the frequency density, except we can see up here the area is proportional to the frequency. So again, technically speaking, we get that. And in most cases, what you'll find is you've got K equals 1, in which case we end up with class width times frequency density just equals the frequency. And that allows us to do that. And I've got to be honest with you, that's really where I'd be going back to in most cases if we were given the groups and just the frequencies if we were being asked to draw it. If you're going the other way around and having to interpret it, you've got to think a little bit more about exactly how the information is given to you. But again, we will deal with that as we come through a couple of examples. But that one there, frequency density is frequency divided by class width. That's your kind of your go-to starting calculation when you're dealing with a histogram. So there we go. We've got some data here. So time of length of how long batteries being lasted, how long batteries last in toys. So we've got time in minutes, frequency. We want a histogram. So off we go. Frequency density, frequency divided by class width. So to begin with, we've got 8, and the class width here clearly is 100. So we're doing 8 divided by 100. Here we've got 15 divided by 100. This one, it's a narrower class width, so we're doing 10 divided by 50, and so on and so forth, and we get those values there. And now we've got to draw it, and what you'll notice on a histogram is you tend not to get sometimes a scale on your vertical axis, or even not get a vertical axis at all, as is the case with this one. So what I'm going to do is choose whatever's appropriate. I've got the height of my bar 0.08, so if I've got 10 small squares there, let's just make that line there be 0.1. And so there's my first bar. And once I've got that one in, let's now just put in all the rest. And there you go. There's my histogram. Right, part B of the question says use the histogram to estimate the median. So what we've got to do is figure out where the median piece of data is in with all of this. So the median, we've got 60 tests, 60 results. So the median is the 30th piece of data. So if we're talking about from our histogram, the frequency is the area. We know our first two columns, 8 and 15, the area of those bars, those things have got a total area of 23. So we need another column that's got an area of 7, and that's going to come from our next category, which is our third interval, which is the 700 to 750 category. So we're going to need that column there. And essentially what we need to do is work out how wide that bar is. So we've got the height there, that's 7. And if we can figure out how wide it is, we can see where this would come to on our scale down here. And that value there would be our median value. So that's what we're looking for. So let's just pull out that bar and have a little look at what's going on. Well, we know it's got a height of 0.2. That's our frequency density. From here, we need to know the width. And clearly all we've got to do is reverse the formula for the area of a rectangle. Base times height equals area. So let's do that as area divided by height equals base. 7 divided by 0.2 is 35. So that means this bar's got a width of 35. So if we go back down to our diagram here, yeah, that means we've got a value there that's 735. And that is the value of our median. And there we go. So our median is 735 minutes. Right. Frequency polygon. Let's quickly just mention a frequency polygon. A frequency polygon joins the midpoints of each bar on a histogram. It basically just gives you an idea of the shape of the distribution. So if we have a look at our histogram from the previous slide, and then we just put a line on joining our midpoints, and now just take those bars away, what you're left with is a frequency polygon. And it can see here, kind of our highest point here is kind of maybe a little bit towards the lower end, so you might be saying it's skewed towards the lower values slightly, but it just gives you an idea of let's say, the shape of the distribution. And there's not a lot more going on with that, to be entirely honest. So let's move on from there, and let's just jump back to a final histogram example. So here we've got an exam question, style question. So we've got traffic on a road, and we're talking about the speeds. And again, you'll notice we've got frequency density at the side here, but we've got absolutely no indication of scale. Sometimes you might get told the number of piece of data in a particular bar, but we haven't got that. The only thing we've got is we know we've got a total of 450 cars. So that's what we're going to have to work with. So we know that area is proportional to frequency. So let's start off by finding the area of all those bars. And that's just as laborious as just counting up the squares. So if we have a look at that one down there, so well, let's just have a look at the number of small squares. So up to this big line here, we've got a 5 by 5, so it's 25 in that area there. And then another 5 is 30, another 5 is 35, and then we've got another kind of 5 lots of a half, that's 2.5. So in total, that area there, we've got 37.5. You'll notice in the red there, the alternative to that would be, rather than counting squares, just 5 times by the height, which is 7.5. It depends on, kind of how accurate your graph paper is and what you're being given and so on and so forth. So either way, we need the area. So we've got 37.5. Let's sort out all the other ones. That's those values there. And let's now work out how many squares we've got. So we've got 562.5 small squares in total. And so 562 small squares represents 450 cars. So each square represents 0.8 of a car. And if we know each square represents 0.8 of a car, that means we can work out how many cars are represented by each column. So clearly there's going to be 30 cars in there. And there's the other values. And a quick check, yep, that all adds up to 450. So we're all happy days, that's that bit sorted. Now, we need, in the question it says, calculate the number of cars that are exceeding the speed limit by at least 5 miles per hour. So the speed limit is 30, so we want these two bars here. Anything that's over 35 from our table or our graph, we can see that's going to be 90 cars. And there we go. Now, in this particular question, we had got that idea of proportional to frequency. So our value for k was 0.8. in this particular case, but like I say, it's easier not to have to worry too much about that and just kind of work with the information that we're given on the graph. And on we go. That's part A done. We've got parts B and C. There we go. So estimate the value of the mean speed of the cars in the sample. Be careful with your statistical calculations because you've got the calculators that will do a lot of the work for you. So I would always use the number of marks available in the question to give you an indication of how much effort you've got to put into these. And it might be, in this particular case, this might only be, part B might only be a 1 or 2 mark question because it's as simple as just banging the numbers into your calculator. So what you'd do, you'd pull up your frequency table in the stats mode and you'd use the midpoints. So for the first one, 12.5 and the frequency 30, put it all into the table and then just pull up your summary stats. Answer comes straight off the calculator. There we go. No need to spend time drawing out tables and manually calculating midpoint times frequency and adding up and proving the divide and all that kind of stuff. Your calculator will do that for you and, like I say, use the number of marks that it says in the question as an indicator of how much work you need to do. So that one was reasonably straightforward. However, doing the median is not straightforward because if you just pull the median value off your calculator, what your calculator will be doing is assuming that the median is just a whole bunch of, and let's say it's coming from this group here, it will assume that basically all your values are 25. which is not what you want to be assuming for your median. What we're doing here is, again, the histogram version of interpolation, which we saw earlier in the video, and we've also seen from cumulative frequency curves. What I'm going to do is go about this one in a slightly different way, in that we know that our median is the 225th value because it's half of 450, and so that puts it into this group here, the 20 to 25 group. And if I've got 30 here, that means I need, let's say, 30 data values from there. That means I'm going to need another 195 to come from this group here. So the area up to the median will include 195 240ths of this bar here, like that. Now the principle is exactly the same. We need to know what this value is down here, and because it's a rectangle, assuming these data values are equally spread out within this group, so we need 195 240ths of the width of the entire group. So let's just do 195 240ths of the width of the group, which is 10, gives the value of 8.125. So therefore our value for our median is going to come from that being 8.125. So our median 28.125 miles per hour. And there we go, histograms done and sorted.